Yes, in this video we start with the WordNet with the synonyms. WordNet is a data set, logical data set that provides synonyms, antonyms for the words. After getting the WordNet, we get also next step to cluster those words, and we just then calculate similarities between pairs of the words using verb similarity, the WordNet score, and then we just try to find the keywords. So let's say WordNet, first of all, we need to import NLTK. Then we just say that NLTK dot download and NLTK dot download again. Two things we have to download here. Number one is WordNet, and then the version of WordNet is OMW 1.4. And after that, we you need to also pip install uh, scikit-learn kit slash and from NLT. Let's do these things. So we already have installed these things, so we don't have to. So for you, need to install those things. Okay. So next, now we import from NLTK dot corpus import WordNet is WN. Let's see the example of the WordNet. We say synonyms equals to set. Okay, we just make it as a dictionary for syn in WN dot synset. For example, we check whether the word happy is what synonyms. Let's check, for example, and for lemma in syn dot lemmas syno dot 8 lemma dot name. Okay, so let's print these print synonyms for word happy. Yes, happy equal to slash just synonyms. Let's see. So we can see there are four synonyms for the word happy in WordNet. For example, felicitious, glad, happy, well chosen. These are the synonyms. So we are not focusing on all four, but we need one synonyms for a particular word. So we choose index 0 as a first synonym for the word. So let's try to get the synonyms. Get underscore since synsates, say, for example, candidate words. word, words with synset equals to empty list words without synsets equals to these words for the word in candidate. So the words word synonyms word underscore synonyms equals to wn dot synsate that particular word. Okay, if length okay, so we say word underscore synonym equals to wn dot synsates. We have a word. If length word underscore synonym greater than 0, then words with synsates dot append word, otherwise else words without synsates dot append word, and we have to return both of them. Word with synsets, words with synsets, comma, words without synsets. Okay, let's try. Copy paste these and return both of them. Copy paste here, and then we say we have nouns, lemma underscore nouns from previous versions. Lemma underscore nouns. Let's check lemma underscore nouns. Lemma underscore nouns here. Remember last time? Yes. So words with synsates. Let's check. Yeah, we got the words that has synsates, and there are also words without synsates. So here we check how the synonyms work for our dictionary. Let's now do the clustering things. For that, we need to, first of all, now clustering. Clustering. Okay, so let's mark it down. Yeah, and now first thing import NLTK from NLTK dot. So we already have this WordNet from sklearn dot cluster import agglomerative clustering. So first of all, we need to define the similarities between define, compute, similarity, matrix. So we have words, similarity, matrix equals to index. Okay. So for word one in words, Synset one equals to wn dot synsets word one. If not synsets one, then similarity underscore matrix dot append and yeah, 1 point default similarity. Okay. Into yes, length words. Okay. Okay. If there's no sunset and then continue. Row equals to for a word two in words. Since it's two equals to wn dot since it's word two. If not, since it's two, if not, then dot row dot append 1.0. Okay. Next, we say continue. Similarity equals to syntax 1.0. We say not wop dot wop. Let's go similarity. Sim sets to 0. Let me explain in the next line. Okay, so now we have row dot append 1.0 minus similarity if similarity not if similarity not if similarity is not none else 0.0, then similarity dot matrix dot append row and return similarity matrix. Then we define clustering function, compute clustering. Here we need number of clusters and similarity matrix. Similarity matrix, and we need n clusters. So first of all, clustering underscore model equals to, we have a model called agglomerative clustering. Yes. Then we have parameters. So now we need to change this num cluster. So next we need to define n clusters equals to num clusters, number of clusters, and then we have matrix equals to pre-compute it pre-computed, and then linkage, we have linkage equals to complete linkage. Then we return this, return this clustering model dot fit underscore predict, and it's a similarity matrix sim. Okay. Metric and okay, it's not a matrices, but a metric pre-computed. We have defined now both of the functions, compute clustering and compute similarity matrix. Now need to define another function that is called define extract keywords. Define extract keywords. We need 4 parameters for that one. Number 1, we need the cluster labels, clusters. So cluster labels would be fine. Words, then words, frequencies, then num clusters. So first of all, we said that clusters equals to, then we start I for I in range num clusters. Then we say for For I, comma, label in enumerate cluster labels. Then we say cluster label dot append. Then we append word, sorry, word I, comma, word if words if are, sorry, not word, words if are, comma, words. Okay, so now we have keywords. So keywords equals to empty list. Then we have mix fr equals to mix words underscore frequency dot. We have values. Okay. Next we have a loop for cluster for cluster in clusters dot values cluster dot sort key equals to lambda. Okay, lambda x x y reverse equals to 2. Keywords brand cluster 0 and 0. Okay. Then we have for word comma frequency in cluster 1. Okay, if greater than 3 and if greater than 0.2 into mix underscore frequency, the top. Then what we are going to do, keyword start append word, and then we return the keyword. function to call all of those functions together. Get clusters. So we need, first of all, 3 parameters: word frequency, words, and then we need num clusters. Number of clusters equals to 8, we define here. So first function that we are going to call is compute similarity. We copy, paste here, compute similarity matrix and word. We need that one, and it returns similarity matrix. We say similarity matrix equals to this one. And second function we are going to call is perform clustering. Perform clustering, yes. Sorry, compute clustering. Compute clustering will need this one. And we copy paste here. And it returns labels, cluster labels, cluster underscore labels equals to this one. And this one is similar to matrix here. And num cluster same. Okay. Then finally, this function extract keywords, and we will get keywords. Cluster labels and words. Okay. Word frequencies. Yeah, word frequency from num clusters. Okay. Everything is fine. We return keywords. So let's test this all combined get clusters function, and let's see what we get. We said keywords equals to this one. Word frequency and words we required. So we have candidate keywords from this final version. We remember this lemma nouns. So we need this lemma nouns as a candidate, but we need to count them. We need to make them as a dictionary. I remember we made this like counter and these functions in order to utilize nouns as a. Okay, so counter, we need lemma nouns here. And word counter becomes noun counters, noun counter, and this is called noun counter. We say noun counter underscore dictionary. So we say noun counter here, word frequency, and this one, and words we have, sorry, dictionary here, counter. And words, we make it like, okay. Oh, yes, I remember one thing. So make it words like nouns only equals to this one. Then we need noun underscore counter condict dot keys. And we need to make it list. Then we provide nouns here. And then we have this original noun counter dictionary. And let's see how this key words work. Equals to lambda. Let me check equals to lambda. Okay, we fixed the issue. There was a small predict spelling was wrong. PRI. There was a spelling error, so we just fixed that one. And then we just call this lemma nouns, and then now we can see we have a keyword BBC, HR, and these 10 keywords. Okay, we need to add keywords from the nouns, or not only, we just also need to add adjectives and verbs, so that we could add keywords from the adjectives and verbs. So we take top two adjectives, most frequent top two adjectives, and one verb with the nouns. So we already use a noun as a candidate keyword. Now we need to add adjectives and the verbs. So let's see how we going to add them. Okay, so we need to find the top frequent adjectives and top frequent verbs from the lemma adjectives and lemma verbs. So we need to define frequent adjectives and verbs, and then we need the lemmas for lemma words. So first we need to count lemmas equals to counter lemma underscore words. Okay, so we say for words that needs to return equals to list for x for a word comma frequency in count lemma start most common, and we need to define, for example, we need two adjectives, so we need to define n here from as an input. When there's n adjectives, there's two, verb should be one. So word start append, and then we return word and return the words. So let's return the needs to be for adjectives frequent adjectives would be like lemma adjectives, and it should be two. And for verb, frequent verb would be lemma verb would be, let me confirm the names from the top. What was the names? Lemma adject, lemma verb. Lemma adjectives and lemma verb. Yeah, correct. So once we have, let's check frequency. Let me comment on that. We don't want to go for process because it takes time. If we are, yeah, we got a gate, one word, and adjectives. Yeah, two words. So final keywords equals to keywords plus FR adjectives plus FR. Okay, print final keywords. Okay, let me check and let's see what are the final keywords. Okay, so now we can see keywords for a web page. Given website bbc.com, we can see there are different keywords. We have aid also, verb and adjectives, three of them. So last, live, Blake, and gate. So we have final keywords. So in next video, we will make it better function and better one or two functions, combine it completely, and you can go through. So let's go through one by one function. We started from importing packages, then we just start web scraping HTML, and then we just start web scraping beautiful soup. Then we just save to the pickle file, load from the pickle file, and then we just start pre-processing steps like count frequencies, POS taggings, and then normalize the words, nouns and adjectives and verbs, and then we just get some words, Synset synonyms for the words, and then we just apply the uh, compute semantic similarity between words using verb similarity, and then we just apply agglomerative clustering to cluster those words, and then we just get clusters, and then we combine clusters, and then we in the end we just add adjective verbs and verbs. Now our method is ready. Keyword extraction method complete is ready. We got the keywords for any web page. In the next last video, we'll combine and make it one main function, and then we call the whole program in the main function, and then we just call the keywords. Then we reference this program to another program, and then we start downloading the data set, and we play and compare with the state-of-art methods how the precision recall and F-score works using hard similarity. So in this sixth part, our keyword extraction method is ready. Seventh part will finalize downloading the dataset and apply keyword extraction uh, evaluations. So thank you for watching. Please keep watching next series. After that, we will make a new series called D-Rank and apply the data sets also. So we have almost 4,000 different web pages. We will test our method on 4,000 web pages. I will teach you how to download those data sets. Thank you very much.